Hello YouTube family, James Green, Short Serious Shenanigans. Getting kind of warm here. I've got that fan turned off so you won't hear it on the video. So, part 2 of making, this has grown, we'll say, from this gearbox, and I've posted pictures. I'll go ahead and show you guys. What this started out as, now this is a gearbox off a cement mixer, was, and I've showed pictures of it before, okay, this shaft, okay, was actually in this gear that was sticking out of the cover and everything, because I've turned what I did in that other video you guys saw where I parted off. This was the end that I parted off, and the reason I know is because it still has that bevel right there. We parted it off and we turned it down to a dimension that'll fit. Now, the reason I did that is because I don't have a complete broach set, which is something I'm going to have to remedy after the bash. Maybe someone will have something out there, who knows. So I'm finally getting to the point where, and I've got some broaches, but they're the small stuff, like 3/16 and below. So I'm gonna have to invest in the larger stuff. So because this is a low turning, high torque, has some DOM tubing, 2.5 diameter, we're going to weld, actually, well, it'll go in like this, but we're going to weld it in. Okay, slip fit, and it is a, what goes on this end, a very tight, very tight slip fit, okay, which is essentially, we'll come in here, we'll weld this up, and then we will obviously mark and locate those as well. I'm going to make a little bit bigger hole here, so because all those do is hold it in place. So we're going to make some through holes for the threads. You know, actually I might mark it, and you know, we'll get it, well, we'll have threads through here and here, so we have the most holding capability. But honestly, there's enough material left there. All it does is because it's keyed, and it keeps it from sliding on the shaft, so that would be more than enough. So we're going to put this in, we're going to weld it on the outside, and once I determine my length here, because I'm not exactly sure, there's still some variance. Once I rebuild all this stuff, I may need to shorten this, so that's why I haven't welded this together yet. I may have to shorten this up, and that's fine. And then we'll reach in here, and I'll actually, on the inside of this, we'll put some weld up in there. Gonna be fun, but we'll do it. So, it snowballed into, they brought the gearbox over so I could match everything up, because I hadn't seen it up close until, you know, got over here yesterday, and I'm like, and I've posted pictures on Instagram, and I've done some little videos and different things, and so this is the shaft, approximately 2.5 inch in diameter, and voila. Okay, a lot of abuse. You saw that coupling that was broke. The bolt that was in here had gotten loose, and it wallowed, literally. This was all swaged out. I had to come in here and grind and work to get this to where it would even slide out of the case because it was so built up. And once we got the case open, I've showed you guys pictures of, and I'll show you, I've got the gear here. I don't know how well it should be able to show up on camera. There we go. Case was only half full of water at one time. Yeah, just, you know, what's water in a gear case? 90 weight oil. It's overrated, really. So, no, just kidding. Anyway, so this is a cement mixer. The failure in the part, what happened was, this was the seal that was up here on the shaft. Okay, so what happened was, over time, as far as I can tell, this is the original seal. It ate up through here and really chewed the groove. And this was the bearing on the end here, and it's just full of rust. Crunchy, lots of burnelling, and just full of garbage. It's a metric bearing, one's ordered, it's on the way. So you can't weld this up. You can't put a pin in there and weld it up, because, hey, we always joke about the hey man, hey bro, can you weld this up, or hey man, can you weld this up? Wanted me to put a pin in here. You know, the suggestion was made, just put some steel in there, weld it up, and turn it down, and then re-drill like either here or cross hole. Well, because this is it's a softer material, because it needs to be, because of the constant in the cement mixer with it operating, it would fracture, and then you would tear this case up. This part is not available. They are basically non-existent. So yours truly gets to make another shaft. So we are going to be doing lathe work. You'll see this. I'm going to set up and I've got to make an adapter for my chuck to go to my rotary plate to be able to cut the 6 splines on here. And so long time since I've done a gear or spline cutting video. Way early on in my channel I had a little bitty rotary table and it ended up breaking. So that was the last time I really did anything with a rotary table as far as making gears on that level. I've used my Spindexer on a lot of small stuff. So we're gonna get that set up, and I'm gonna make that adapter plate. We're gonna do all our dimensions and turning down. This is just gonna be a slip fit, and so we've already got some material in here. We'll show that. So this is gonna be, I don't know how many series, and I'm gonna show you guys. Because this isn't something I do a lot of, but I'm getting more and more of it. So it's just, you know, my hobbiness, if you will, because the guy has another cement mixer. Just that's my ringtone. That's funny. Sorry, I thought I had it turned down. That's hilarious. Anyway, I apologize. So he's got another cement mixer like this. Going to be a lot of machining on it, and it's got the same problem. So he's like, "You're my man. Go ahead, get it figured out." He's like, "Hey, you're a vet, man. You do this. You're awesome." Because job shops, you guys know, downtown, they can cause, their way of we don't want to mess with it was, they told him, from what I understand, was leave a large non-refundable amount of money and we'll get to it in a month. And he's like, "I don't have a month." So anyway, it's no gotta have it overnight hot job. Yes, it is, but it's gonna take me a couple days to do it manually, and he's perfectly fine with that. But when we get done, because we still gotta wait for parts to show up, you know, got a seal to show up, and so there we go. I hope you guys enjoy. Nose is itching. There's cottonwood floating around here. Anyway, I've got the material. This is a piece of material I've had for a while. Okay, a piece of shaft material. Unknown exactly what type of material it is. Pretty good stuff. Here's some of the chips we've been producing out of it. And of course, nice, pretty blue, beautiful cobalt blue. You know, I played with a couple inserts off camera to figure out what is working well. Rather than pull that out, I'll show you. I have some inserts that I got a while back, and these are some Tungalloy. Now they are CNMG 433, but they've got a really aggressive chip breaker, and they work really well. I did try some other ones that Seco had sent me, and some other ones. They just weren't performing. Again, I don't know exactly what type of material this is, so this one happened to be performing the best, and here's the information on it. And it is a pretty big radius. You know, generally I want to go 432, but I figured out the angle and got it to where it's working. And so we're slowly, this material within insert like 755, or I watched Brian Stenga's video the other day, and I'm going to have to do my machine. I hadn't done it yet. And he showed you guys a link in the bottom down there. I will link his video with a card at the top up here, okay, of showing the various the changes of the true RPM on the machine. So I'm going to do a video like that, but I'm going to be using a manual, and it's the same chuck here. I'm going to use a manual RPM gauge so we can see the differences versus his digital and my manual. So back off that subject. We're working down. I cut this longer than what I needed, so I'd have to you know, where I could really hog down on this. This is kind of soft material in a sense. Well, not soft, but you know, it's soft compared to what I've been working in 304 stainless for the last umpteen months. So our major diameter that we're wanting to get down to first is at the very end is 2.5 inch. It's going to be the slip fit. Okay, this is our major diameter. I always like to work from largest to smallest, and so here we go. I'm actually turning back a little further so when I part off. So 2.5 inch, we're almost there. I had to feed a little more out, and we're actually at, for this, take a measurement over here, which this is all going to come off anyway, smaller. Oh, I bumped it. This is going to be where our finished diameter is at down this end. So we are, if I can do this, 2 inch 512 thou. Yeah, 2 inch 512 thou. So I'm going to turn the camera on, get started, a little bit of noise. I'll leave you guys wide so you can see what we got. Well, actually, I will try to zoom a little bit so you guys can see a little turning action. And here we go. 30 thou depth of cut. And the feed rate, let me tell you, let's see, we're A1, 2, well actually it should be A2. Move over. So A2 and 2, we're actually, let me see here, A2, 2, and we are on, I'm trying to make sure I read this correctly. Oh, no, wait, okay. Actually, Z1. Oh, actually, let's go B. Now, we'll leave it with, well, actually, it's the same thing. B2, 5, C3, we're going approximately, let's see, I'm sorry. I'm usually better at this. I'm having a bit of a moment here. A2, we're going about 25 thousandths revolutions per minute, approximately. That seems to be working pretty good. We'll do another 30 thou depth of cut. Pretty aggressive feed rate. There. Stuff's kind of tricky to get it to not ball up on your fine cuts. 10, 20, 30. Let me move you guys over my shoulder here so you can see, because you can't see anything that you need to see, and it's fun to try to get a good angle in video of this stuff. This is always the challenge. So I don't want to get the camera right in the middle of the mess here. Okay, we'll try this. Okay, literally over my shoulder here. All right. Should be able to see that. I'm trying to see if you can see it on camera. Yep. Okay. So here we go. 30 thou depth of cut. There's 40 thou depth of cut. This insert likes a deep, aggressive cut. It really likes it. It doesn't like the really shallow cuts. Well, alright. Yeah, this material, somewhat stringy, not sure exactly what it is. So, okay, now we're going to come in here, and our major diameter that we need is going to be back here, but so we said 512 approximately. So we're 512, so we're going to dial in 6. Again, this just has to slide through and fit inside of that tubing. So we're going to get it just under, like 249 or 248 is fine because it's sliding in, and I'm going to make a pin and everything. So we're going to come in here. Touch. And because I know this tapers, I'm just going to do a skim across. And I'm actually going to speed up because I've found on the higher RPM on this, it'll turn a better finish if you're doing a thin cut. And by thin, I mean a shallow depth. I know this shaft, there's a little bit of taper, but I've been whittling down on this. So I'm going to let it go across, kind of do a spring pass. So I have my own method to the madness here. Everyone does it a little different. Yeah, okay, alright. Just back here. Because this had several different steps on it. I love these chip hooks. Go by hand, spring cut. Alright, because that dimension that's back here, we're not worried about finish because it's going to slide inside of the collar that we made. It's actually going to slide in, okay, this end here, so it can be a little under, which is perfectly fine. I just wanted to make sure, so we're 2-inch 50 thou and 7/10, 8/10. So I don't know if you can see that on camera, if it'll try to get the camera to show. So these are Starrett number 216s. I like these. These are pretty handy. So just a skim pass. I'm going to dial in 3 thou, which is going to be fine. It'll get us under, and it'll be a slip fit because the inside of that tubing is not perfectly round. It's just a little bit of oblong would be the word. Get rid of that just to make, you know what, because I'm really hesitant. This is where when this stuff gets stringy, and you have to be careful of, this will grab, and I'm standing over here to the side, and this can grab and be very deadly. So what I'm going to do very carefully, I'm always pulling this type of stuff out. I'm just so careful about, if you're new to metalworking, and you really shouldn't be doing this with your bare hands, but if you be careful, and these are cool. So you have to really be careful. I'm so safety conscious minded because I got hurt so many times growing up as a kid, just being a kid, you know, playing, working, yada, yada, yada. Being a medic in the Army, I've seen lots of injuries, dealt with a lot of them. So I'm always safety conscious of, you don't stand directly over, you know, right here. I'm actually standing off, you can see over here to the side, because if you're standing right over it watching, and you always kind of peek, and depending on the material, if it'll grab that's why I'm a big fan of the 5C. When you don't have those jaws hanging out, if you're working with stuff that's notoriously stringy, on smaller stuff that because I do a lot of short round parts, it's great for that because it's smooth. But that can be so dangerous. I mean, here's kind of a safety point. Standing, you never want to stand directly, because if something happens or an insert breaks, you know. And these are polycarbonate, and I do, if I'm working on stuff that's spraying real bad, I actually have my face shield, and these work good too. You know, if you're worried about, and you have glasses like me, get you one of these face shields. You know, kind of sounds funny while I'm talking. If you're working with brass or cast iron or cast steel, I put this on, even standing back here, because that stuff sprays 360 degrees, and if you've ever had something in your eye, it's not fun. So rather than show you a bunch of continued hogging down and digging, and it's getting hot, I gotta put my sweatband back on here. So anyway, I'm slowly gonna work down. I'll show you guys what we got going on. The next video will be me setting up in the mill and getting ready to do the cuts on the splines, and we're going to create our own. Matter of fact, I dug through my stuff, and my father-in-law, you know, he passed away over 3 years ago, and Lee Allen Stevens, every time I see something with Caterpillar on it. So anyway, sorry, it broke up. Wow, I got a bunch of Caterpillar bolts. Anyway, so if you guys are curious, yeah, Caterpillar had stamped. It's a very good high-grade bolt. This is what I'll be using, and it's a 1/2 by 13. I've got a lot of cat bolts, and so I thought, you know what, that'd be perfect, because like we said, this is a mixer. It's turning less than probably say 300 RPM, and it's just a constant, you know, it's a cement mixer. They mix stucco and cement and stuff like that. So anyway, there you go. I hope you guys have enjoyed this. Gonna be leaving next week to go out to the bash in California. Want to remind everybody again, I am going to be bringing a bunch of tools, a bunch of vintage tools, a bunch of vintage books. Bring cash. That's the easiest thing. That way, for all the transactions, because I'm going to kind of Stan put me in charge of, hey, would you help supervise the trade tables? Sure. So kind of as the person in charge of that, you guys bring cash, because the internet signal and phone signal there to do PayPal is not that great. So that's what I highly recommend. Stan has boxes there. If you want to mail your stuff back, you'll be responsible for paying the shipping, but he'll provide a box. You box it up, and then you label it, but you've got to pay him the shipping. Talk to Stan about that. And so lots of stuff going to be going on. Going to be doing the Standage Granite tours. I'm going on both of them on Friday. I'm actually coming in Thursday night, so I know there's going to be lots of pre-mix, mingle mix, post bash mix, clean up from the bash, because I know I'll stay the morning after. I'll help Stan clean up and whatever. That's just how I am. And if you guys are going to be in the area around late the next day and you want to help clean up, please come over and help. I'm sure Stan's not gonna mind helping clean up and pack recycle and everything. That's just kind of, you know, let's not leave an entire load on, you know, 1 or 2 people to help clean up the mess. So anyway, looking forward to seeing everybody out there, and we're really excited, starting to get lots and lots more projects like this, and you know what, loving it. My public email address, if you guys and gals have any questions, eagledustoff37@gmail.com. Instagram handle is @eagledustoff37, as well as Twitter @eagledustoff37. So there you go. I hope you guys are enjoying this. The "Hey man, can you weld it up, bro?" is what I'm calling this series. This was episode 2. Part 3 will be when we're doing mill work on the rotary table in the Bridgeport. So there you go. I hope you guys have enjoyed it. I love hearing from you guys. If you don't do social media, email me. I love talking to you guys. Thanks for watching. Until next time, be safe, take care of yourself and your family, because remember, at the end of the day, you and your family's all you got. Get out in the garage, your shop, whatever, outside, make something, because you know what? This stuff is fun. We'll talk to you later. Bye-bye.